Hey there, campers. Today we are going to cover section 9.3. So we're taking a break from the like graph and polar stuff, and we're going to be talking about the complex plane. So complex numbers. So complex numbers, they occur in two different forms. They occur in rectangular and polar. Rectangular is what you're used to from like your Algebra 2 or Math 120 or intermediate algebra. So if A and B are real numbers, then Z equals A plus BI is the rectangular form of a complex number. So this is what you're used to. Well, we can take this and we're going to convert it into polar. So A plus BI may be written in polar form as R cosine of theta plus R sine of theta times I. So that right there is a whole kit and caboodle. But you can shorthand it if you want to. You can write it this way, or you could say RCIS of theta. This is not a new trig function. It's just a kind of a shorthand of this. And just remember that the I goes with the sine. It does not go with the cosine. So let's go and define the next two things. So magnitude, if you have a complex number in rectangular form, then the magnitude is the distance from the origin to the point A comma B, and is given by the absolute value of Z, which is the absolute value of A plus BI, and it's equal to the square root of A squared plus B squared. So it's basically just the distance formula or Pythagorean theorem. And then if your complex numbers in polar form, if it ever talks about the argument, they're just talking about the angle, it's just theta. Okay, so let's go ahead and we're going to plot these, and then we're going to write it in polar form. So we're just converting. So plotting is pretty straightforward. You have the real axis, and then you have the imaginary. So whatever number is just off on its own, that's the real part. And whatever number is in front of the I, that's the imaginary. So in this case, there's a 1. So you're just plotting the point, and negative 1, 1. And there you go. So there's the plot. So now we got to write it in polar form. So polar, remember, you need an R and you need a theta. So the R, that's the distance from the point to the origin. So it's really talking about the same thing. It's the distance from the origin to the point. So it's the square root of A squared plus B squared. Also, if you made a triangle out of it, hey, it's Pythagorean theorem. So your R is the square root of 2. And for those of you who are savvy enough to realize what you have, you've really got a right triangle. This side is negative 1, that side is 1, so this means the hypotenuse is root 2. That's a 45, 45, 90. So your theta, it's not 45 because it has to rotate from 0 all the way over there. So theta would be 135. So there's your R, there's your theta, so we can write it in polar form and express the argument in degrees. So it's already in degrees, so we're good to go. So that means that Z is going to equal R, or root 2, CIS of 135 degrees. Okay, let's hit example 2. So write each complex number in rectangular form. So now it's in polar, you gotta convert it back into rectangular. And with this way, there's nothing special about it. Just evaluate the trig functions. So cosine of 120 degrees, that's a half. negative half, sorry. And then sine of 120 is root 3 over 2. And then whatever is out here, this number just distributes. So negative 1 plus I root 3. Okay, so that's a good introduction to complex numbers in the polar system. So I'll go ahead and stop this video here, and then we'll continue on in the next one.